Okay, today for 4.4, we are going to talk about congruence, most specifically congruence in terms of shapes and transformation. So here in 4.4, let's a congruent figure. So the congruent figure is just any two shapes that are pretty much the same, and then a congruent transformation. And that is a rigid set of motion that does not change the size whatsoever of the shape. The shape is pretty much the same. It's just either rotated, maybe reflected, or translated. So let's do some an example here. If I had a right triangle, and let's make that right triangle decently sized here. And there was another right triangle, but it looks like that right triangle might have just been maybe reflected over a line or moved a little bit. But I noticed that that other right triangle has the same amount of sides. It looks pretty much the same, and there are corresponding sides with one triangle to the other. So we can say that those two right triangles are congruent figures, and the congruent sides to that triangle, I noticed that that bottom side matches this bottom side, that back matches that back side, and I'm just gonna put tick marks to indicate congruent sides. I'm going to also, let's talk about congruent angles. The congruent angles are the angles that are the same size, place in the shape compared to the other. So this would be a congruent angle to that. That right triangle would be congruent to that. And that angle, and to indicate congruence is we give them the same amount of tick marks. Let me draw a series of shapes for you. So if I had a shape that looked like this, had another shape that looked like this, had another shape that looked like this, kind of. Imagine all the lines are straight here in this particular set of images. We'll just suspend. So if I were to figure out which of these images are congruent, even though one is kind of rotated from the other and flipped upside down and moved, I can say that those triangles are congruent to each other, and those rectangles, because they have the same size, their angles are the same, they are congruent to each other. Now let's talk about the type of transformation that could have caused one to the other. Let's look at the triangle first. And there could be more than one transformation, so a rigid type of transformation. So I looked at the triangle. It looks like it flipped upside down, so it reflected and then it moved. So this is a composition of two types of transformation. The triangle has a translation and a reflection, whereas the rectangles, it looks like if I picked a certain point here, it looked like it could be rotated like on a Ferris wheel around that point. So that could have been a rotation, just like if it was like on a clock. Let's do another example here with some more triangles. Let's say I had a triangle, like using this just because it makes my work a little bit more accurate. Here and here and here. And then this one is, if I get this right, it's here and here. And if I were to mark some angles, I notice that this angle congruent to that, and that congruent to that. Like so. If I then had to go through and mark up some other sides that are congruent to each other, the same side in the middle, these are congruent to itself. We'll go through that later when we get into triangles using our reflexive property. These outside is congruent to itself. The other opposite angle is congruent to that. And then finally the last angles here are congruent to that. If I were to say, oh, well, what kind of congruent transformation that probably happened? Well, one seemed to kind of be a reflection, probably, or it looks like if I took the point of one, let's say took the point of this one and I want to match it to the other point of that one, I would have to rotate it this way. But because I want to match it, it's going to end up here, and then I'd have to translate it back down that way. So it is probably a combination of a rotation with a translation.